Hello class, good morning. Weekend, can you check who's still not here? Vinesh. Before this, did he join the class? I mean, he's not sleeping. Can someone call him or text him? Okay, so never mind, we just start first. Okay, so today we will go to the next subtopic. There is a main met satellite. Okay, so this is the last subtopic in chapter 3. Okay, and then we will discuss about the online test that you just answered, yeah, on yesterday, I think. Okay, so we continue the next subtopic, that is chapter 3.3. Avinash is still not here, right? 15 should be 19. Okay, so let's see for 3.3 main met satellite. So the International Space Station, right? ISS can be seen from the Earth because of its large size and orbits at the height of 498 kilometer. Okay, so we can see ISS, okay, from the Earth, okay, because of the size, okay, and it's large, and its orbits is just the height of 498. Okay, for the MESAT satellite, it's difficult for us to see, okay, because the first thing of the size, the small size, and the orbit is a height of 35,786. So this one is much higher than the ISS, right? So satellite can move in orbits, okay, at a specific height and suitable linear speed, okay. So the first activity is how we want to determine the linear speed of satellite. So I'm sure you already know, okay, when the when we launch a satellite, okay, so it will revolve around the Earth, okay, it will rotate around the Earth, okay, and it will move with a certain speed, okay. While it will move with a certain speed, okay. So we want to calculate the speed, okay. So we want to calculate the speed, okay. So we already know, okay, so that actually when there are two objects, okay, there is a gravitational force that acting on it, okay. So let's say we take the example, okay, for the Earth and the satellite. Okay, so for the Earth and the satellite, so you can see here there is a gravitational force that acting between these two, okay. There will be an gravitational force that acting on these two. So, and also already learned about the centripetal force. So any object that rotates, okay, that rotates around something, so there must be a centripetal force, okay, that acting on it, okay. So this centripetal force is actually moved towards the center of the object. Okay, so this is, they say, the centripetal force. So because of this, okay, we assume that it's actually the gravitational force is equal to the centripetal force. Okay, this is for the planets. Okay, for the planets, for and the satellites, planets with the moon. Okay, planets with the sun. Okay, so we assume that the gravitational force is actually equals to the centripetal force, because both is actually the force that acting between two objects and it attracts, okay, between these two objects. Okay, so this is the first equation. So we equate that the gravitational force between satellite and the earth is actually equals to the centripetal force. Okay, and we already know the formula for the gravitational force. There is gmm/r square. So this is the gravitational force between the satellite and the earth. Okay, and then we already know that actually this gravitational force is actually equals to the centripetal force, that is F is equals to mv square over r. So if we equate these two equations, so we will get like this: gmm over r square is equals to mv square r over r. So this one I can just, okay, cancel the common factor here. Okay, and then only left by this, right? And then I will just cross multiply gmr equals to v square r. So this also the common factor, I can cancel it. Okay, so this one is r square. Okay, so if I cancel one, it will left only one like this. Alright, and then if I want the linear speed here, so it means I want v here, so I will move the r to the left side. Okay, so it will become divide. And then the v square, if you change to the left side, it will become square root. Okay, so the answer is, if you want to calculate the speed of the linear speed of the satellite when it rotates, okay, around the earth, so this is the formula. Okay, so it's actually derived like this. Okay, so this is the formula. Okay, so Gm is a constant. G is the gravitational constant, that is 6.67 times 10 power or negative 11, right? So that one is constant. M also constant. M is the mass of the earth. Okay, so that one is also constant. Okay, and the linear speed v depends on the radius of its orbit. So means when the object rotates, okay, when the satellite rotates around the earth, okay, the speed of the satellite when it rotates is depend on the radius. Okay, because G and M is a constant, so mean it's only depend on the radius. Okay, and also the, sorry, yes, G is the 6.67 times 10 power or negative 11. Okay, and it's, I'm sorry, it's quite noisy here. Okay, and then the radius here, okay, so the radius here is actually, let's say this is the earth. Abang roti, yes. Okay, so this is the earth, so this is actually the R, okay, capital letter R, that is the radius, okay, and this is the H, okay, the height, okay, of the satellite from the surface of the earth. So if you want to calculate this formula, actually this formula is come from here, right? R. So this R, you must consider the height of the satellite also. So just don't take only the radius of the earth. We have to take with the height of the satellite also from the surface. Okay, so that's why R plus H. Okay. Alright, what is the requirement so that a man-made satellite can be launched to keep orbiting at the specific height around the Earth at radius orbit r? So what is the requirement that we need? It's actually the linear speed. Okay, so we need to know the speed of the satellite when it rotates, okay, around the Earth. So means it will not come back, okay, to the Earth, right? Like the China, I think China's rocket, satellite, right? So I think it's already landed. Okay. Okay, for this one, a GPS satellite is orbiting the Earth. So calculate the satellite's linear speed if it is at an altitude of h is equals to 20,200 kilometer. Okay, so this one, if you want to calculate the satellite linear speed, okay, so you need to use this formula. Okay, so can you please try to calculate? Our Venus number is 019, is it? 019450. Okay. Oh, Avinash is another call with I don't know who. Cannot call him. Did you text him? Weekend, did you text him? Maybe I should put in the group, parents group.
Kenyang.
2,500.232496.28. Ma, my answer lari so many. Are you using the correct? What's yours? Did you round off or something? So we use this formula, right? Did you square root it? Oh my god. 6.67 times 10 power of negative 11. And then the mass is 5.97 times 10 power of 24. Okay, and divide by the radius is 6.6, 6.37 times 10 power of 7. Did you add with the height of the so see? So the height is 20,200 times 10 power of 3. Yes. Should be like this when you calculate. It's either you can change the kilometer to meter, just multiply by 1000, or you just can change the prefix because kilo is 10 power of 3, right? So it should be like this. I will calculate with you 3.7, 6.7 plus 20, 200 exponent 3. So I will get like this. Okay, and 6.37 exponent negative 11 times 5.97 exponent.
Teacher,
Yes.
isn't that 6.67 times 10 power negative 11?
Which one? The answer is it?
No, I mean the G value.
Oh, G value is negative 11, right? This one. 6.67 times 10 power of negative 11.
Yeah, but teacher put 6.37 if I'm not mistaken.
Oh, that one is the R. This one is the radius, not the G.
Oh, okay.
Uh, this one is so where did I calculate this one? 4.97 is 24. Okay, and then you have to divide by the answer. Okay, you got this one, and then you have to square root the answer. So I got 2,129. Hmm? So anyone got same like mine? Why yours got 2496.28? Check yeah. Actually, I already did this one with 4M just now. Yeah, and I think the answer is correct, 2129. Okay, let's check your question first. I put 6.37 for G. Am I? Oh, really? Wait. 6.67. This is all the Abang Roti fault. Wait, am I? I put the 6.37 before. Okay. Then let me count again. Alright, so I got this one. So let's check again. I put 6.67, right? Okay, and 5.97. Okay, and then I divide with 6.37 exponent 7 plus 20 exponent 3. Okay, I got this one. Okay, and then I square root the answer. I got 2178. Anyone got same like mine? 2178.6. Oh my god. Same. Eugene, Lashmi, you are same answer like me, right? So for those who got 2,500, how you got 2,500? But if you let's say you forgot to square root, right? The answer should be like 4,000 or some four something, right? Not like two something. Oh, you forgot to change the meter. Same. Okay. Anyone still didn't get the answer? Avinash, are you here? Hmm. Yeah, km change to meter. So this one I change to meter, right? 20,200. I multiply with 10 power of 3 because I know the prefix, the kilo is 10 power of 3, right? One left again. Okay, so that's the answer. Anyone still have the problem to get the answer for this question? Okay. So, what will happen to the satellite if the linear speed of the satellite is less than required linear speed? So, means for each orbit, we can like consider here for each orbit they have to have the constant their own speed. So, let's say if we launch the satellite and the orbit is doesn't follow the speed of the each orbit, it will fall back to the Earth. Okay, so means here the satellite will fall to a lower orbit and continue to revolve towards the Earth until it enters the atmosphere. So the movement of the satellite at a high linear speed against air resistance will regenerate heat and eventually cause the satellite to burn. So let's say this is the Earth and we launch a satellite, and let's say this is the orbit of the satellite, right? So let's say the speed is not same, it's not equal to the linear speed. Okay, for this orbit. Okay, let's say it's lower. Let's say if you want to revolve using this orbit, the speed must be 300. Okay, but the satellite is only like 290 meter per second. Okay, so means it's much lower than required. So what will happen to the satellite? It will fall to the another orbit. Okay, lower orbit, and then after that it fall to another one. Okay, until it enter the atmosphere. So when you enter the atmosphere, you know that in the atmosphere they got the air molecule. So the resistant force will produce. Okay, the resistant force will produce. So this resistance will produce a heat. Okay, so that's why when any rocket or any satellite that fall back to the Earth, it will be burned. Okay, because of the air resistance. Okay, air resistance produce heat, so this heat will burn the satellite. Okay. So for the activity 3, so this one you have to compare between the geostationary and non-geostationary satellite. So for the geostationary satellite, so a satellite that move around the Earth at certain height. Okay, so this one means it have a constant value. So let's say for the satellite, if the orbit is 20,000 kilometer, so it will stay at the height of 20,000 kilometer. It will not change the height. Okay, so this special orbit, okay, we call it as a geostationary Earth orbit. Okay, it will stay at 20,000 like that. It will not change the height of the satellite. Okay, and then for the second one, it move around the Earth in the same direction as the direction of the Earth rotation on its axis. So let's say the rotation of the Earth axis is clockwise. So it will move the same way as the Earth. So it also will move in the clockwise. Okay. And the third one, the orbital period is T is equals to 20 hours, 24 hours. That means it's equals to 1 day. Okay, so that is the same as the period of the rotation of the Earth. Okay, so it will take 24 hours to make one full complete circle. Okay, so it's same like the Earth. So 24 hours also, okay, for equals to 1 day, right? So it takes like the same time, okay, same period. Okay, and the next one is always above the same geographical location. So let's say we launch it from Malaysia. So it will stay, okay, on top of Malaysia. Okay, so it will not change the place. Okay, so that is the geostationary satellite. Right. So how about the non-geostationary satellite? Okay, for the non-geostationary satellite, okay, so a satellite that move around the Earth at changing orbit height. So it can change the height. So maybe first time it will be at 20,000 kilometer, 20,000 kilometer from the Earth. Okay, and then maybe after that, okay, it will change to 19,000 kilometers. So it can change the height, okay, of the orbit. Alright, and then it's normally in a lower or higher orbit than the geostationary Earth. So it may be low, maybe high than the geostationary Earth. For the geostationary Earth, it always constant. So they say it's 20,000 kilometer. It will be like the same height, 20,000 kilometer. It will not change the height. It will not come down or it will not go up, right? And the next one, the orbital period is shorter or longer than 24 hours. Okay, so this one, let's say for geostationary satellite, it takes for the satellite to rotate one complete circle in 24 hours. But for the non-geostationary satellite, it depends, maybe shorter or maybe longer. Right, and then the non-geostationary satellite above different geographical location at different time. So mean it will not stay at the same location. Okay, maybe the first thing is at the on top of Malaysia. Then after that, maybe it moved to the Philippines. Okay, maybe after that it moved to the USA. Okay, so that's the example for the non-geostationary satellite and also stationary. So what is the characteristic? Right, so after this, oh, sorry. Before that, we see the similarity. Okay, just now we only see the difference, right? So what is the similarity? So let's say if you want to calculate the speed, okay, the speed of the satellite when it orbit the Earth, you can use the formula V is equals to Gm over R for the linear speed. Okay, so let's say if you want to calculate what is the speed of the satellite, okay, when it rotates around the Earth. So you just use this formula, okay. So it's can use for the geostationary satellite and also for the non-geostationary satellite. And also for the period, for the orbital period, okay, you can use the formula T is equals to square root of 4 pi square R cube over Gm. Okay, so this one you can apply to the geostationary satellite and also the non-geostationary satellite. So let's say the example, you want to calculate the period for the satellite A. Okay, so you can use this equation. Let's say if you want to use for the satellite B, okay, but it has a different radius, you can use this one. Okay, so both for the stationary satellite and non-stationary geosatellite, you can use both this equation. So this is the similarity. So just now what we learned is only the difference. Okay, so we compare, right? So we try to compare, okay, for the geostationary satellite and non-geostationary satellite. So first we see about the direction of motion. Okay, for geostationary satellite, as I told you before, so let's say the Earth is rotates, okay, rotates on its axis, let's say on the clockwise. So the geostationary satellite also will follow clockwise. So that is the geostationary. Okay, for the non-geostationary, it doesn't need to be the same direction as the rotation of the Earth. So let's say just now I said the Earth rotate on axis, so example is clockwise. Okay, so mean for the non-geostationary, it can also rotate anti-clockwise. Okay, so it doesn't follow, it doesn't mean need to follow the direction of motion of the Earth. Okay, for geostationary, it will follow. Okay, and about the period, you already know for the geostationary satellite, when it rotates, okay, around the Earth, okay, the time must be 24 hours, okay, for it to make one complete rotation. But for the non-geostationary, okay, it can be shorter, it can be longer. All right, and then for the position, I already told you, let's say we launch from the Malaysia, so it must be always at the on top of Malaysia. Okay, so they're above the same geographical location. But for the non-geostationary, it will above different geographical. So like I said just now, maybe it will go to Philippines, maybe it will go to Malaysia, maybe then it will change back to Japan. Okay, so it doesn't need to have to be at the same place all the time. Okay, and then the function. What is the function for geostationary satellite? So the function is for the communication satellite. Okay, for the non-geostationary satellite, it's the Earth imaging, GPS, okay, or weather forecast. Okay, so this is the function for the non-geostationary satellite. Okay, so the example for geostationary satellite means the MEASAT. Okay, and the non-geostationary satellite like TuneSat, RazakSat, PIPIT, and ISS. Okay, so this is the difference, okay, for each aspect for the geostationary satellite and also for the non-geostationary satellite. So are you clear about this one? Anyone? Why Avina said couldn't enter? We've already masuk. Oh, sorry, I just read your text. Okay, anyone want to? That link didn't work. Really? How about others? How others how you enter the Google Meet? Yeah. I already see the picture. So next time if you cannot enter, just tell me. I will invite you. Okay. All right. Okay. So next we see about the escape velocity. What is the escape velocity? Okay. For the rocket, right? So before we launch the rocket, okay, we need to calculate the escape velocity. So what is the escape velocity here? So the escape velocity is the minimum velocity, okay, needed by an object on the surface of the earth to overcome the gravitational force and escape to outer space. Okay, so we already know, okay, on the earth, okay, on the surface of the earth there is a gravitational force. Okay, so let's say this is you. Okay, so there is a gravitational force acting on you that we call it as a weight here, right? So if you want to go to the outer space, you need to overcome the gravitational force first. Then after that, you can go to the outer space. Okay, so but that one is for person. So we take example, okay, let's say a rocket. Okay, and then let's say if you want to launch a rocket, so we need to overcome the gravitational force of the earth first before it being launched to the outer space. So that velocity that we need to overcome is called as the escape velocity. Okay, so that is the minimum velocity. So let's say it's lower than that. Okay, you cannot, let's say if you launch, let's say the example, the escape velocity is 11,200. Okay, let's say you launch the rocket and then the speed is only 10,500. Okay, so it's much lower than that. So the rocket, if it's you launch, it will come back to the earth. Okay, so that's why this is called as a escape velocity. Okay, the minimum velocity that required, okay, that needed by an object, okay, to overcome the gravitational force. Okay, so it can go to the outer space. Okay, so when the escape velocity is achieved, so it can achieve when the minimum kinetic of F of an object is able to overcome its gravitational potential energy. Okay, so you already know that any object that the gravitational potential energy is actually depend on what? Depend on the position. Okay, so let's say if you can overcome this gravitational potential energy, okay, you can go to the space, okay, but you need to consider the speed. All right, so because you know the energy can be changed, right, can be changed. So I give you an example. Okay, so let's say this is the surface, okay, and this is the ball. So for the ball, the first at this position, okay, at A, let's say, it consists of gravitational potential energy. Okay, and then when it come down, it will change to kinetic energy, right? Okay, and then when it go up again, it will change back to the gravitational potential energy. So what we can conclude here, the energy can only change it can only change form, right? But it cannot be destroyed. So let's say if I say here, A, the gravitational potential energy is 20 joule. So here at the kinetic energy also will be 20 joule. Okay, and then we go back at the original position here. So it will be 20 joule also. Okay, so here you can conclude that actually the energy cannot be destroyed, it can only change form. So it seems like here too. Okay, the gravitational potential energy changed to the kinetic energy. Alright, so when the minimum kinetic energy of an object is able to overcome the gravitational potential energy. So you can see the change here from the gravitational potential energy change to the kinetic energy. Okay, so the minimum kinetic energy, what is the formula for kinetic energy? Anyone still remember? What is the formula for the kinetic energy? You learned this one on chapter 7, I think. Science form 2. Half mv square. Yes, very good. So, half mv square. So, this is the kinetic energy. You can see there is a velocity here, right? You can see there is a velocity here. So, means if you can reach this velocity, okay, you can achieve the minimum kinetic energy to overcome the gravitational potential energy. Okay, so when the escape velocity is achieved, when can reach this velocity from the formula half mv square, if you can reach this velocity, okay, and the velocity, the kinetic energy, we call it as a minimum kinetic energy, okay, you can overcome the gravitational potential energy, then you can go to the outer space, right? Are you clear about that one? Anything you want to ask? Okay. So the next one again, okay, you have to derive the formula for the escape velocity. Okay, so just now I already told you, right? It can only change form. Okay, so it's actually like this. Half mv square, the kinetic energy is actually equals to the gravitational potential energy, this one. Okay, so it's equal. So let's say if I change place here, okay, it will become 0 like this. Okay, I move to here, this is plus, and move here, it will become minus, so this one should be 0. So this is how we get this equation. Because some of you ask, well, how can this one be negative, right? Energy cannot be negative. It's not a vector, it's a scalar. So how we can get negative? By this one. We equate the equation. We assume that the kinetic energy is equals to the gravitational potential energy. Okay, because the energy cannot be destroyed, it only can change form. Okay, so that's why I get this one. Okay, so from that, we try to um, I'm not sure I can wait. So from this one, GMM over R, right? Okay, so I can cancel this one. So it will be V square GM over R. Okay, so V square over 2 GM over R. This is V. Okay, and then I cross multiply, V square R is equals to 2GM. Okay, and then V square is 2GM over R. Okay, and then this is square changed back there to become square root like this. Okay, so this is how we derive this equation. Okay, so remember just now also we learned about the linear speed, right? Also V. Okay, so that V is actually when the rocket or when the rocket or when the spaceship is already been launched. Okay, or when the satellite is already been launched. So what is the speed when it's rotate the orbit? That one is for the one that we used just now, linear speed. Okay, that one is to calculate the velocity when it's already rotate the earth. Okay, for the escape velocity is actually is not, is still at the earth. So you want to calculate what is the velocity that is need, okay, to be launched to the outer space. Okay, escape velocity. That one, the V1 just now that we learned, that one is already orbit the earth. So what is the velocity that the satellite when it orbit the earth? Okay, but for this one, it's still at the surface. You want to launch it, so you have to know what is the escape velocity. Okay, so don't be confused. Okay, so this is the escape velocity. So this is the formula. Okay, so can you try to calculate the escape velocity from the earth by using this formula? Two GM over R 11,181.38 others. Same. Actually, if you round off, it become 1.12 times 10 power of 4. Okay, so it's correct. Okay, because this one, they give you the answer in the standard form. Anyone have a problem to get the answer for this one? Okay, so the next one you have to state the factor that affecting the escape velocity v. So again, I already said for the factor that affecting, you have to refer back to the formula here. Okay, over r square. So basically for g is actually a constant value, right? So it means it doesn't affect, okay, the factors, it doesn't affect the escape velocity. So the one that affect is actually the mass, okay, and also the r, the value of r, that is the radius. Okay, so that's the factor that affecting the escape velocity. Okay, for g is not affecting because that one is a constant value. So this is the formula. Alright, so benefits and implication of escape velocity. So what is the benefits here? So number one, why the earth can maintain a layer of atmosphere around it. Okay, so why do you think the earth can maintain a layer of atmosphere around it? Because you know that around of the earth there's got an atmosphere, right? And then inside the atmosphere they got the air molecule. Okay, so how does the air molecule, okay, can stay inside of the atmosphere? So it will not go to the outer space. Must do in the standard form in exam. It doesn't matter. You can give both answer also. So why do you think that the air molecule can still stay in the atmosphere? It doesn't escape to the outer space. Gravity holds the air molecule together and the molecule is too slow to escape. Yes, correct. Okay, because the high escape velocity of the earth, you already calculate just now, is around 11,200. Okay, while the molecules in the atmosphere it move an average of linear speed at 500. So mean is lower, right? Lower than 11,200. So mean it cannot escape. If you want to escape, it need to have 11,200. It need to move with the speed of 11,200. So that's it can escape. Okay, but let's say if the less than 11,200, it will not escape, so it will stay inside the atmosphere. Okay, so what's the reason? Because of the speed is lower than the escape velocity of the earth, so it will stay in the atmosphere. Okay, very good. We can. Okay, for number two, why commercial aircraft cannot escape into outer space? So same as the air molecule just now, because the velocity, the speed of the aircraft is usually 200 meter per second. So it's much lower, right? Because you know for the escape velocity for the earth, it must have like 11,200. So it just move at 250 meter per second. Okay, even the fastest one, it move with the supersonic linear. Okay, so the speed is only 2,200 meter per second, still far away from the 11,200. Okay, so that's why, because it's below the escape velocity, so it will not escape to the outer space. Okay. And how can a rocket achieve the escape velocity from the Earth and send the spacecraft into outer space? So this one is actually you need a more fuel to burn. So inside the jet, usually there we use a kerosene. Okay, the fuel is a kerosene. Okay, so means that need a lot of kerosene to burn, so it can produce the higher thrust. Okay, higher thrust force. So when there's a higher thrust force, means the velocity also will be increased. Okay, it will produce the high velocity. So if achieve more than 11,200, it will escape to the outer space. Okay, it will escape to outer space and it will orbit the Earth. Okay, according to the speed. So the launching of rocket requires a large quantity of fuel, okay, to produce a high thrust that enable the rocket to achieve the escape velocity of the Earth. So hence it can send the spacecraft into outer space. Okay, so it means if you launch at any object that is below than escape velocity 11,200, it will not be enter the outer space. It will still stay at our atmosphere. Okay. So for this one is actually just for your knowledge. Okay. So for Venus, Mars, okay, if you compare Jupiter, okay, for these three, of course, the Jupiter has the highest escape velocity, like 60,216, okay, 0.6. Okay. And for this one, I want you to calculate. Okay. Anyone still remember the formula for the gravitational acceleration? Gm over r. Okay, very good. Okay, so try to calculate this one by using the formula. So this is the mass and this is the radius. Okay, and then you have to compare the gravitational acceleration. Which one is higher? Anyone of you planning to get the vaccine? No one. And I think for those who are 18 above, yours is not 18 yet. I forgot. Maybe if you have a sister or your brother, they can starting tomorrow, right? Six. No, today, 6 p.m. Okay. Did you get the answer yet? Sun has higher gravitational force. Against acceleration compared to Moon. Okay. What is the value of the gravitational acceleration for the Moon and the Sun beacon? Hmm? One got 10 power of 11, one got 10 power of 17. Which one is correct? Others, maybe negative 11. Right. Okay, so let's see whether it's correct or not. Okay, for this one is wrong actually. Okay, don't use this one. I think I got 2 point something lah. I remember I just calculate 0.2 something like that. Oh, that one is for no, that one is for escape velocity. Sorry. So I it's different, right? Yeah, it's km over r square. What did you write just now? Wait, I check your equation first. You give me gm over r. It's r square, right? I check first. Gravitational acceleration. Yeah, it's r square. Gm over r square. So I should get 1.62 meter per ms negative 2. Try to calculate again. Good. Okay. So 1.62 for the moon and sun is still at 274, the gravitational acceleration. Okay, so why does the sun has the higher gravitational acceleration? So this is because of the mass. Okay, the mass of the sun is much higher than the much higher than the moon. Okay, the mass of the sun. Okay, how about the escape velocity? Can you calculate the escape velocity for me? You already have the paper, right? So you can use that one to refer the value. For the escape velocity, there is V is equals to 2 gm, right? over r, if I'm not mistaken. Check first, is it correct? 2 gm over r. Yeah, square it. Yeah, this is the square. Let me put here. Oh, square root. Yeah, not square. Square root. You will get like 0.023 something for the moon. So it should be like 2.37, 2 point something. I cannot remember, but it's 2.3 something times 10 power of negative 2 for the moon. 0.024. Others, can you get the answer? Same. Okay, so this one is actually wrong. Okay, so your answer is correct. 0.024 times 10 power of negative 2. So 2.37, I think, times 10 power of negative 2. So this is the answer. Okay. For the sun, you will get 6.18 times 10 power of 5 meter per second. So if you compare, of course, the escape velocity for the moon is very low, right? It's only take like 0.023 meter per second. Okay, to escape from the gravitational force of the moon. Okay. So the moon has a low gravitational acceleration, so we already compared this one. And the sun is the largest body in the solar system. So gravitational acceleration on the sun and escape velocity from the sun have the highest value. Okay, because the first one because of the velocity for the mass. Okay, for the mass of the sun. So if you compare with any other planet, okay, or moon, okay, you can see the escape velocity is very higher. Okay, so if you compare between all other planets. All right, so the number 3. So discuss whether escape velocity from the Earth for spacecraft X of mass 1,500 kg is different from spacecraft Y of mass 2,000 kg. So instead, the escape velocity is same for these two objects because they have the different mass, right? So is the escape velocity is still the same? No, it's not same. Okay. Can you give me the formula for the escape velocity is this one, right? Okay. So you can see the escape velocity is only influenced by the mass of the Earth and also the radius. Okay. So it doesn't, the mass that will not influence the escape velocity. Okay. This is the mass of the Earth. Okay. So what it doesn't matter whether your spacecraft or your jet or your rocket is 2000 kg or 5000 kg, so it doesn't matter. Okay, what does it matter here is only the mass of the Earth and also the radius. Okay, the radius of the Earth. So the escape velocity will always be the same. Okay, are you clear? Okay, so it should be the same because mass will not affect, only the mass of the Earth and also the radius. Okay, are you clear about this one? Okay, you have to refer back to the formula. Okay, refer back to the formula so you see what does it influence here. So it's only influenced by the value of G. G is constant, right? So it doesn't matter. The mass of the Earth also constant. Only the R. Okay, R also constant, right? The radius of the Earth always the same. Okay, so means you just calculate just now the 11,200. So that is the escape velocity of the Earth. So it will not change. Okay, unless suddenly the mass become bigger or the radius of the Earth become bigger or become smaller. So that one is very impossible to occur. Okay, so that means the value, the escape velocity is same. It doesn't matter what is the mass of the rocket you want to launch, it will not influence it. So for every object, the escape velocity is the same. Yes, for the Earth. But for the other planet, the escape velocity is different because it influenced by the radius of the planet. Okay, is it clear, Sajid? Okay. So for this one, you have to calculate the linear speed. Alright, this is linear speed, not the escape velocity. So the linear speed is, what is the formula? V is equals to gm over r square root. Okay, so the linear speed is actually when you already launch the rocket and then the rocket rotate the Earth. Okay, so what is the speed? Okay, that the rocket rotate, okay, around the Earth. So I think this is the formula. Can you check again? Because for this part, there's a lot of formula, right? So maybe if you want to study for this part, you have to put a list of formula for this equation, so it will not mess up. Yes, R plus H. So this one again, like just now, you have to change to meter. This one is already launched to the Earth, so you have to consider the R plus H. Just now for the escape velocity, the object is still on the surface of the Earth. So the radius is only, you consider the radius of the Earth only. So when you already launch the rocket, now they already have the height of the rocket. So you have to add with the radius of the Earth and also the height of the rocket. Did you get the answer? For this chapter, you need to very be careful when you use the calculator. 7,504.82 meter per second. Any other answer? Six point nine. Avinash got 6.9 times 10 power of 12. The answer is 7,404.82. Did you calculate it correctly? You see this equation, Avinash? So later, I will like, because actually I asked for your subject teacher, okay, give me names, okay, for those who are very um took very, you know, press, how do I say this? Take part for the PDPR for very well, you know, like always on time, okay, submit your work, okay. So for those who are nominated, I will text you, okay, and because I need your address, I will post something for you, okay. Okay, 7,400. Avinash, did you calculate this one? The equation is correct. Did you forget to square root? Because yours is 10 power of 11, right? Yeah, 10 power of 12. Did you forget to square root? Usually we forgot to. Teacher, why? So what is the present? So you have to wait lah. But don't worry lah, I cannot afford like iPhone like that, cannot lah. Okay, just a small gift. Okay, as to show my thank you for you. Avinash, do you get the answer? Do you want me to teach? Okay. So what's wrong? You type it wrongly, or you forgot to square root? Okay, done. You finished chapter 3. I forgot to change your meter to meter. Okay, so be careful for the unit. Okay, now we're done for chapter 3. So we got like 3 more chapter. So I will go for chapter 4. Okay, and then I will brief for you for your project. Okay, so I'm giving you a choice. Okay, the first one is actually you can do any project that is actually based on what we already learned. Okay, any science, any physics project. Okay, so me the you can do any topic you want. Okay, but you have to propose to me first. What is your topic? Okay, you have to show me what's your topic. You have to tell me what's topic, and if I approve, then you can continue doing it. Okay, that is my first cadangan lah. Okay, and then my second one, I'm the one who will set the topic, and you will do the project based on the topic that I give. So which one did you want? So the topic is chapter 1 until chapter 4. For me, chapter 1, I think no project for that one. Chapter 2, chapter 3, chapter 4 until heat. Or maybe you can, if you don't want, you can do until chapter light also. Okay, so which one do you want? I will give you one example. What is the project? But the topic you have to choose on your own based on what we already learned. So which one do you want? The second one or the first one? I decide the topic. You propose me the project, or I set up the topic for you. You have to find the project for it. Which one do you want? You don't want both. Choose by ourselves. Yeah. I like that one too because you know, uh, there's a lot of for you to choose, right? If I set one topic, maybe some of you will choose the same project. Okay. So chapter one until chapter four, like oh no, what you can choose from chapter light. Okay, light. Chapter one no because no project. Okay. Chapter two is forces and motion. Chapter three is gravitational. Okay, yeah, gravitational law. Okay, and then for the fourth one is a heat. So you can choose any for this from this four chapter. Okay, to do the physics project. Okay, I will brief about this one later. I will show you how you have to start to think first. For this part, you just try to think first. What project do you want to do? Okay, my example. So let's say if you want to modify a car. Okay, you make a model, a car model. Okay, so just like the characteristic of the car, how is the shape of the car? Okay, what is the material made of it? Okay, so that is the model of the car. If I give the topic, let's say if I choose heat, right? There's not like many physics project that we consider we can do in the topic heat topic. Yes, there's some experiment that some project you can do, but the problem is you cannot do in the group. Okay, if you can do in the group, it's easy. Okay, if you, this one you have to do individual. So if I cannot choose something, so that's why I said you can better is for you to choose what topic do you want. Okay, if let's say the project you need a lot of money to do it. Okay, so later you need to find, okay, I don't want to trouble you. Okay, so that's why I said, okay, because this one you have to do individual. So you choose what topic that is you think that you can do on your own. Okay, let's say if the school open, then maybe if you want to do in the group, it's okay. You can discuss. You can stay after school doing it together. Okay, I can guide you. But for this one is, you know, because I'm not sure whether the school will open on 13 June. You can see the case now, right? So I'm prepared for you is what you have to do on your own. So you choose what you think you can do on your own. Okay, is it okay? School, yeah. School open, forget. Okay, 6,000 I think they will not open the school. Okay, so you have to do because this one is for your PBD, right? So you need to have at least one project. Okay, if not you have two project. But I think in the time like this, one is already enough lah. Okay, so what you have to do now, okay, you try to Google. Okay, there's a lot of physics project actually you can do. Okay, and then you try to Google, you find something that you think you can do, okay, on your own, and I will tell you what you have to do next. Because after this you have to take picture, you have to do the presentation. Okay, you have to show how it works. Okay, the process of you doing it, you have to record of that, all that. Okay, what is the process? Okay, let's say you make a model of car, so you have to see, you start by taking, let's say you take a polystyrene or cardboard. Okay, so you design it. Okay, maybe you start need to draw the design first. Yes, you have to present, of course. Starting from the start, you choose the topic. Okay, and then what's the material need? Okay, what is the process? Okay, what is the result? Okay, so that's all that you need to present, and I will give mark based on that. So this time I can hear your voice. Must we do folio teacher? So just take it. That one you can do in the PowerPoint. That one you have to do in PowerPoint. You can record using your phone, right? Okay, take picture, okay, and make a video. Okay, not a long video, just maybe a short one. How do you assemble it? Okay, and then after that, put in the PowerPoint. Okay, put it nicely. Okay, and then after that, you have to present. Okay, in the Google Meet. Folio no need folio. Only the by using the PowerPoint. I don't need the folio one. Only by using the PowerPoint and also the model. I need the model. Okay, let's say you are designing a car. So I need the model of the car. When is due date? Okay, I'm giving you like 3 months or 2 months. Is it enough? Yeah, but don't think 2 months is very long, huh? 2 months is not so long because you have to find the material, okay, and then you need to assemble it, make sure it really works, okay. The one that I'm interested, the one they use a bottle of water and they try to put the bottle of water like a propeller. So it like when it release the bottle, so the bottle will produce the thrust force and the car will move forward like that. Some more, yeah, other subject also I know. Chemistry also, I know bio you only need to do the what? Biology you need only to do the folio like that, right? Yeah, pickle jeruk. That one is easy, just put cuka right like that. Ikan masin and then you can but this one physics is because you want TP6 actually you have to mereka cipta, you have to invent something. Jeruk, yeah, I know, but that one is very common, right? So for physics, you have to need to apply what you have learned. Okay, what you have learned from Form 1, Form 5, Form 1 until Form 4, what you learn about force. Okay, and I'm interested someone that uses circuit. Okay, you can find in Google. There's a lot of physics project. Okay, but make sure it's not going to burden you because of the cost. Okay, if you can, it's okay. If you cannot, then don't. Okay. Yung bomb. Oh, chemistry invent bomb. For chemistry, what? What is the project you need to do for chemistry? Maybe later, yeah. Okay, I start early so you have more time to uh, think. Right? Teacher, can we do the electric related work? Yes, as long it's not burden you and it's not dangerous to you. Okay, I'm okay. Because bomb is actually also under physics, nuclear, right? Okay, don't invent something dangerous. Okay, you can do on your own and you will not have any trouble later. You can do electric, of course, because you already learned in form 2, I think, electricity, right? Sure, you can. Okay, and Shopee also got a lot of things. Okay, you can try. Okay, so just Google it first. Okay, and then you can start to propose to me. 6-4. Okay. So you can start to propose me what's the topic you want to do, and I will say whether it's okay, you can carry on or not. Okay, and I will give you the format how you want to do the presentation later. Alright. Okay. Any question for the project? No. Okay. So I will give the PowerPoint later in the group. Okay, how you can do the presentation. But first, I think better you try to find the project first. Just Google. There's a lot of it. Okay, especially for the light. Some of you can do the kaleidoscope, I think. Yeah, the periscope. See? Yeah, that's a project. That's the application, right? So that's the example. But yeah, you did before. Vacuum cleaner, yes, also can. It's up to you. But don't buy the vacuum cleaner and say, teacher, this is my project. No, you have to do from, you have to assemble it. Okay, or maybe you can modify it to make it more accurate. Let's say buy all the materials in Shopee got sale. Yes, that's why I said in the Shopee they got a lot of materials. Uh, okay, let me tell you something. On, let's say someone already done periscope. Okay, others cannot do. You have to find others, other thing. Cannot copy from your friend. One project, one person only. Okay, one project, one person only. Cannot do the same thing. That's a lot lah. You just need to Google. Okay. Alright. Okay, so for the next, we have a class again. Don't think so. Oh, on Saturday, the class is as usual. Okay. I want to discuss for the test and also the question that we still have to we still not yet finished, right, on the handout I give. Okay, so we continue that one and also the test. For the test, can I ask you something? Because I saw your marks. Okay. um, for me, if you want to get the band 4 or band 5, right, at least you have to score like 70 above. 70, not 17. 70 above. So here, if I see only like two, three people only got. I rasa no. I'm scared. They say it's sour. I don't want. Okay. So I'm thinking to do it again. Okay. I'm thinking to do it again because if not only got three of you got band 4 or band 5. Other got only band 3. Okay. So I'm thinking to do it again. I will give like almost the same question as the test. Okay. So I will teach you first. Then you take again. Okay, but a different question lah. But same, only maybe I change the number, something like that. Okay. So we see you on this Saturday at 2 p.m. Okay. So thank you. Alright. Bye. Take care.
Thank you,
Thank you,
teacher.
teacher.
Welcome.
Teacher.
Alright. Bye bye. Welcome.
Thank you, sir.
Thank you, teacher.
Bye. Okay. Welcome.